Hello! Today we will talk about an interesting mechanism of gas exchange in the lungs and tissues, which occurs every second in our body during breathing. To do this, let's remember what breathing is. Respiration is a set of processes that ensure the entry of oxygen into the body. Its use in the processes of oxidation of organic substances with the production of energy for life and the removal of carbon dioxide from the body. Stages of breathing include 1. External respiration, the pulmonary ventilation, the entry of air into the body and the exchange of air between the environment and the lungs. 2. Diffusion of gases from the alveoli into the blood. Transportation of gases by blood. 3. Diffusion of gases from the blood into tissues and cells. Internal respiration, the consumption of oxygen by cells and the release of carbon dioxide. You can see a vivid scheme of this process on the screen. Tap on it and take a look. Gas exchange in the lungs. Let's figure it out. Tap on the main organ of gas exchange, the lungs. A person breathes atmospheric air, which contains 20.9% of oxygen and 0.003% of carbon dioxide. Exhaled air contains 16.3% oxygen and 4% carbon dioxide. Gas exchange is based on the difference in concentration of gases in the alveoli and capillaries. In the lungs, oxygen with the alveoli by diffusion, along the concentration gradient, passes into the blood, and carbon dioxide from the blood through the walls of the alveoli into their lumen. Tap on the alveoli on the screen and look at it. First in the complex of alveoli in the lungs, then separately. The total wall thickness of the alveoli and blood capillaries is about 0.4 micrometers. The diffusion rate of carbon dioxide is 25 times greater than that of oxygen. Therefore, despite a small difference in the concentration of carbon dioxide in the alveolar air and pulmonary capillaries, it has time to diffuse. Tap on the scheme of gas exchange in the alveolus. Study in detail. Oxygen and carbon dioxide dissolve in small amounts of blood plasma. They are mainly transported in a chemically bound form. The main oxygen carrier is blood hemoglobin, each gram of which binds 1.34 hundredths of a cubic meter of oxygen, forming oxyhemoglobin. Tap on its diagram. Carbon dioxide is carried in the blood mainly in the form of chemical compounds, sodium and potassium bicarbonates, as well as in the state associated with hemoglobin, carbhemoglobin. At high altitudes, the atmosphere is rarefied and the partial pressure of oxygen is very low. As a result, when breathing, less oxygen enters the lungs. Tap on the scheme of transport gases in the blood, namely the vessel. Remember, oxygenated blood enters the organs and tissues. Gas exchange in tissues according to the same principle as in the lungs. From the capillaries, oxygen enters the tissue fluid due to the difference in concentrations, then into the cells and enters into oxidation reactions in the mitochondria, the internal respiration. According to the same laws, carbon dioxide from the cells through the tissue fluid penetrates into the capillaries, then into the veins. Tap on the diagram. Consider quantitative properties of respiration. Stomp on the diagram of the lungs and find the diaphragm. 1. At rest, 500 milliliters of air enters the lungs during inhalation. This is the tidal volume, the TV, and the same amount is obtained during exhalation. 2. After a quiet breath, you can still inhale 1.5 tenths of a liter of air. This is an additional volume, the IRV. 3. With the deepest exhalation, you can still exhale 1.5 tenths of a liter of air. This is the expiratory reserve volume, or ERV. Together, these values make up the VC, the vital capacity of the lungs, the largest amount of air that a person can exhale after the deepest possible breath. VC equals TV plus IRV plus ERV equals 3.524 liters. After maximum expiration, 1 to 1.5 tenths of a liter of air remains in the lungs, which is called residual. There are special devices for measuring these indicators. A spirometer is a device for measuring the volume of air from the lungs during the greatest exhalation after the maximum inhalation.